Good morning, my dear students. Today we'll be revising an important topic in physics by name work power energy. The concepts of work power energy we get both in first year as well as in second year in many chapters. As it is from work power energy, every year 2 to 3 questions on an average will come. Last year, 2 very easy and highly scoreable questions have come in recently concluded NEET 2026. These are the 2 questions that have come in the exam. As you are aware of, this particular bit involving law of conservation of energy and another question involving the power. So these 2 are 2 simple bits that have come in the exam. Okay. Now, as every one of you know, to be perfect, to get perfection in the entrance examination, you need to have the concepts clear and the short notes very ready and handy, and you have to revise the short notes as many times as possible. Perhaps something like this will do the job for you. Then, this is the short notes of work power energy. Work done by a constant force. That means a force remaining constant both in magnitude as well as in direction. So work done by that particular force which is constant in magnitude and direction is given by Fd cos theta. Theta is the angle between the force and displacement. Theta is the angle between force and displacement there. Work done by the force is Fd cos theta. As everyone knows, AB cos theta is nothing but A dot B. So Fd cos theta is F bar dot D bar. Okay, immediately we need to recollect some small point from a scalar product or dot product. Generally, any vector A we write as AXI plus AYJ plus AZK. So force vector we can write as Fxi plus Fij plus Fzk. Similarly, displacement vector dxi plus dyj plus dzk. F dot D, you have to recollect Fx dx plus Fi dy plus Fz dz. So work done is Fd cos theta, provided force is constant in magnitude and direction, F dot D, and F dot D is given by this one. Okay. If the force is not constant but variable, then you have to go for integration there, and work done by variable force comes out to be integral of Fx dx plus integral of Fy dy plus integral of Fz dz. Your teacher has put little bit of efforts to make you recollect the necessary integration there. There's a simple list of integration equations. How to calculate work done by other methods? Whenever force displacement graph is given, area enclosed by Fd graph will give you the work done. Area enclosed by Fd graph will give you work done. So this is one area which is positive, this is the other area negative. So this total area will give you the total work done. Okay. Now, in this particular topic, we are just showing you the slide of this particular one. Okay, sir? Yeah. Right in this particular topic there, work power energy. We are interested about the energy term there. Any body moving with a velocity v will have the kinetic energy given by all this formula, you know, half mv square, p square by 2m or half pv. Okay, then what the formula for potential energy means? When you speak about potential energy perfectly there, potential energy is mg into height of center of mass. Don't just say mgh, mg into hcm. hcm means the height of center of mass of the body above the chosen reference axis. Potential energy mg hcm. You know work energy theorem. Work done by all forces acting on the body is equal to change in kinetic energy. Work done by all forces is changing kinetic energy. What is the law of conservation of mechanical energy? Suppose a body is moving under the action of only conservative forces like gravitational force. There is no friction at all. When the frictional forces, resistive forces are absent and body is moving under the action of conservative forces, the total mechanical energy of the body will always remain constant. So total mechanical energy is sum of P and KE, that will be constant everywhere. NEET 2026 simple question is based on this sixth small point. Okay, we'll be discussing the bit. Just see. The next thing is that, see here. Yeah. The next slide here. Under the heading of power there, whenever you are talking about power, average power happens to be total work done by total time. For example, average speed, total distance by total time. Whenever average comes, it is a ratio between two totals. So average power is total work done by total time. How to calculate the power at any instant of time t? Power at any time t. Power at any time t means whenever you want the power at any instant, you have to go for simple differentiation, dw by dt. Average power is total work done by total time, and instantaneous power dw by dt. Okay, every one of you know that any spring that has been elongated or compressed by an amount x will have elastic potential energy given by half kx square. Okay, in this particular topic, too often you have to recollect the basics of differentiation. Okay, what is the velocity from kinematics? As you know, v is equal to dx by dt, acceleration is dv by dt, v dv by dx, and these are the necessary simple differentiation things you have to be good at, not only here, almost in many chapters in physics. Very ordinary things, just if you put a little bit of effort, anyone can master it. Okay. Then, the first question right here, which has come in NEET 2026. The sum of kinetic energy and potential energy of a simple pendulum bob is given as 0.02 joules, directly given in SI system. What is the speed or velocity of the bob when it is at the equilibrium position? Okay, that too he is asking approximately, and mass of the bob is given in grams. This is given in SI system, this is given in grams. There's a only twist in the question there, units difference, otherwise a soft question. The solution is written right here there. So whenever a simple pendulum bob is moving, then there is no friction anywhere. When there is no friction, friction is absent, you can go for law of conservation of mechanical energy. You can say that the total mechanical energy of the body at any point will remain constant. So we are interested about the bob at the mean position there. So total mechanical energy at A is nothing but potential energy plus kinetic energy. But the total potential energy is already given as 0.02 joules. In the question it is given that total mechanical energy is 0.02. What is the potential energy? When the bob is at the lowest point there, the lowest point is taken as a reference there. So height is 0, potential energy is 0. So kinetic energy half mva square. You convert the mass of 20 grams into kilograms there. So mass into kilograms. These two terms get cancelled. Va square is 2 and Va is root 2. Root 2 is 1.414. He said approximately there, approximately. So 1.414 approximated to 1.41. A happy question to perfectly gain the mark. Okay. The next thing. You see, the other question that has come in recently concluded NEET, unfortunately got abandoned. The power of a crane which lifts a mass of 1000 kilogram to a height of 20 meters in 10 seconds is dash. Okay, G given as a regular value 9.8. What do you mean by power? Unless said power means average power, total work done by total time. So power of a crane means what type of work crane will do? Lifting work. Work done by the crane in lifting the body divided by corresponding time taken. What is the formula for work required in lifting a body through a height h? mgh. So work done in lifting the body is mgh divided by time. So all the values are directly given there. Substitute. Once again, 1000%. We need, anyone need to get the mark right for that particular bit. Okay? Okay. Then comes, after the last sessions, NEET questions there, some standard questions which will give you the overall idea about the complete chapter. Okay, we have tried our level best to give you there. Listen carefully. The third bit. A body of mass 4 kilogram is freely released. That means velocity at point A is 0 from certain height. Okay, the height is not given. Where air resistance force of 32 Newton is acting on the body. Okay, right in the region where it is left, there is a constant air resistance force of 32 Newton. Find the work done by the air resistance force if it takes 2 seconds to reach the ground. The body is consuming 2 seconds to strike the ground. In that time, what is the work done by the air resistance force? Okay, first point. It is a combination of 3 simple concepts. There is kinematics, there is Newton's laws of motion, and there is work power energy. But in all the chapters, small points we have to use. Okay, first thing is, you have to draw a free body diagram. This is a body of mass 4 kilogram that is freely released. Any body freely released will be falling down. So this is the direction of motion. Okay, then let us say that it will be falling down with an acceleration A. Now, what are all the forces acting on the body? What are the first force acting on the body? Weight act down, mg. So G is given as 10. So m into G, 4 into 10, 40 Newton. Air resistance force. Any resistive force acts opposite to the motion of the body. So motion is down. So air resistance force acts up. Okay. So weight 40 Newton down and air resistance force 32 Newton up. Under the action of these two forces, the body is coming down. Okay, downward force is the dominant force and the body is coming down. Now, after drawing the free body diagram, what do we do in the Newton's laws of motion means use the formula net force is equal to mass into acceleration. What is the net force acting on the body? Any force that acts in the direction of motion is positive. Opposite to the direction of motion is negative. So 40 is positive, that is acting in the direction of motion. 32 Newton is acting opposite to the direction of motion, 32. That is the mass of the body, 4 into acceleration. So 8 is equal to 4a. Acceleration comes out to be 2 meters per second square. So first we have to calculate with what acceleration is the body moving. Then comes kinematics. The body is freely released. You know, initial velocity is 0. Acceleration. We have just now found acceleration as 2 meters per second square. Yes, S is a distance covered. Distance covered is nothing but the height from which it is released. That we don't know. We have to calculate. Time. It is taking precisely 2 seconds to reach the ground. From this data there, we have to calculate S there. S is equal to ut plus half at square as you are thinking correctly. So distance covered by the body is nothing but h. That h comes out to be ut is 0, half 2 into 2 square. This comes out to be as much as 4 meters. Now comes the concluding point for it. I want to know work done by specifically air resistance force. Work done by any force F is Fd cos theta, as we have seen. Work done by air resistance force means air resistance force into displacement to cos theta. Now you need to be slightly careful, my dear students. What is the air resistance force? The air resistance force happens to be given as the 32 newtons there. Air resistance force is 32. It is acting up. What is the displacement of the body there? So the displacement of the body happens to be 4 meters. That is acting down. Just now we have seen the body is getting displaced down. Cos theta. Theta is the angle between F and D. So air resistance force up, displacement down. The angle between them is 180 degrees there. Is up and down, opposite directions 180, cos 180. You have to be perfect with cos 180 there. Cos 180 is minus 1 there. And if you do it, this comes out to be minus 128 joules. That will be the answer for the question. Okay. The question that has come in many entrances in the NEET itself, not less than 3 to 4 times over the years, is this particular very regular model. Position of a body of mass 4 kilogram moving along x-axis is given by x is equal to tq plus t square plus t plus 1. That means when the body is moving there. So time keeps on changing. Time will not wait for none of us there. So time never waited. Time keeps on changing. As time changes, position x also keeps on changing. Find the net work done by the resultant force. I want to know work done by resultant force. That means work done by all forces I want. Okay. Find the... In the previous question, I was asking you what is the work done by air resistance force only. Previous bit was work done by air resistance force. Let me just show you that point. Yeah, here we want work done by one specific force. Okay, now here we want work done by the resultant force. That means all the forces. What is the work done by the resultant force acting on the body? In first 2 seconds there. Yeah. Even the wording, first 2 seconds, you have to catch a little bit like this. Then, coming to the first point there, listen. What is the basic idea here there? Once again, it is a simple 3 steps question here there. It is 3 steps bit. Intention, I am writing the 3rd step first. Okay. I want to know what is the work done by the net force, the resultant force. The work done by the resultant force or net force is nothing but the change in kinetic energy of the body. There's a work energy theorem. Work done by all forces is always change in kinetic energy. What do you mean by change in kinetic energy? Ke2 minus Ke1. Ke2 means half m V2 square minus half m V1 square. Half m we can take common there. Half m into V2 square minus V1 square. So to get the answer for this particular question there, work done by the resultant force, you have to use this particular point and get the answer. Now the question becomes more simpler. How to find V1, how to find V2. Mass of the body already given. Okay, we have to just dump it there. The only thing is how to find V1, V2. Now comes the little bit of good thoughts from you. xt relation is given. Okay, x is given as tq plus t square plus t plus 1. xt relation is given, but I want velocity. As we were having a quick revision at the beginning of the class there, from x, how do you find velocity means simple but important differentiation. So velocity comes out to be dx by dt. Okay. Already we know what are the basics of differentiation there. Just showing you the particular point just for half a second there. So under the heading of this differentiation there. So these are the points you have to be good at. Differentiation of t cube comes out to be 3t square. Differentiation of t square with respect to t, 2t. Differentiation of t is 1. Differentiation of any number is 0 there. So now recollecting where we stopped here, there and continuing, x is equal to this one. So how to find v means dx by dt. Each of the term you have to differentiate. Differentiation of t cube comes out to be 3t square. Differentiation of t square is 2t. Differentiation of t is 1. Differentiation of pure number is 0. So here we have the equation saying that, so v is equal to 3t square plus 2t plus 1. Now I want to know what is what do we want? We want work done by the resultant force in first 2 seconds. Okay, now what do you mean by first 2 seconds there? First 2 seconds means, here I am writing with a changed color here there. First 2 seconds means from the beginning of the motion up to 2 seconds, naturally. First 2 seconds, from the start of the motion up to 2 seconds. When the motion starts, that time only we press the stopwatch and the time recorded is 0. Or every one of you know that whenever the motion starts, that initial time at which it starts, we take it as 0. First 2 seconds means t1 is 0. And the final time comes out to be 2 seconds. Once again, I am repeating, this is one of the highly celebrated question in work power energy over the years in different entrances, including your NEET and our NEET. Okay, now velocity of the body is equal to, just now we have seen 3t square plus 2t plus 1. Now, when the time is 0, initial time is 0, I want to know what is the initial velocity. At the initial time 0, what is the initial velocity? Put t is 0. So put t is 0 there. The first 2 terms comes out to be 0. It is 1 meter per second. Put t is equal to 2 seconds. Then we can calculate the velocity. This is, put t is 2. 2 square means 4. 4 into 3, 12. Put t is 2. This comes out to be 4 plus 1. So this is as much as 17 meter per second. So you know the initial velocity, you know the final velocity. I want to know what is the work done by the net force. What is the work done by net force means half into 2. Already we have discussed this point, changing kinetic energy, K2 minus K1, half m V2 square minus V1 square. So what is V2, half into mass? What is the mass of the body? 4 into V2 square. 17 square. 17 square comes out to be 289 minus V1 square. V1 is 1. V1 is 1. So 1 square is 1. 289 minus 1, 288. So you have to multiply 2 with 288. So just multiply it and that will be the answer for work done in joules. Comes out to be 576 joules. There's the answer. Okay. My dear students, you are parallelly trying the questions and definitely getting the answers, I am sure. Yeah. Then, next model. Generally, under the heading of work power energy, they ask the questions based on graphs there. This is the other bit. A body of mass 4 kilogram moves along a straight line and its velocity varies with time t as. Okay, velocity time relation is given. Suppose a vehicle is going, as time changes, generally velocity changes. So the velocity is changing from plus 14.14 to minus 17.32 velocity changing. So in 10 seconds of time, velocity changes like this. I want to know 2 things there. What is the total work done in first 10 seconds? And average power developed in that concerned 10 seconds. What is the total work done in first 10 seconds and average power developed right in the first 10 seconds. Okay, but particularly the question up to the first extent came in many entrances. If they ask power, slightly new bit, and that would be little challenging bit, very little. Okay, now there is a little bit of arithmetic we have to be slightly good at and slightly recollecting it. Okay, proper arithmetic, proper numbers, and so on. Listen. So I am writing right here, there. Just see. A body of mass 4 kilogram. So mass of the body is given as 4 kg. Okay. The solution I am writing with the red color here after there. See. So the mass of the body is given as 4 kg. I want to know what is the net work done. What do you mean by net work done? Total work done. Total work done by what forces? Naturally, all the forces. He is asking net work done. Net work done means work done by whatever forces that are acting on the body. Total work done. What is the formula for total work done by all forces? Work energy theorem does teach us that total work done is change in kinetic energy. How to calculate kinetic energy? Half into mass into velocity square. Mass is directly given and velocity is given not directly. Velocity is not given in wording there. Velocity changing from this to this, he is not telling, but graphically they are telling. We have to just understand the graph and proceed. Okay, see here there. Now, this is the time now. So what is the starting time means T1 is 0. What the ending time means T2 is 10 seconds. Here the time 0, here 10 seconds. Now you ask yourself, at T is 0, what is the velocity of the body? Every one of you know how to understand the graph. So whenever there is a graph like this, for example, velocity time graph, intention I'm drawing little separately there. So whenever there is a velocity time graph there, at this time, how to find the velocity means you have to go like this. Suppose at this particular time, you want to know what the velocity means, you have to go it. It will strike, it will intercept here, there, come like this. This is a corresponding velocity. So at this particular time, t, what the velocity means, you have to come like this. Okay, now, first time writing. At this particular time, t2 there, what the velocity means, you have to come like this. So at this particular time, what the velocity means, minus 17.32 meter per second. This is the velocity at t2. At this time, how to find velocity means you have to come like this. Already I told now, please. At this time, how to find velocity? Come like this. At this time, how to find velocity? Come like this. Minus 17.32. Okay. Now listen. At this time, how to find velocity? You have to come like this. At this time, like this. At this time, what the velocity means? This only. Okay? At this time, what the velocity means? This one. At T1 is 0. This happens to be the V1 there. So, we have clarity here that what are V1 and V2 there. V1 is 14.14. V2 is minus 17.32. One is plus, one is minus. But it should not scare us. No. Okay. But the only thing is, how to find V1 square? Somebody directly do 14.14 whole square. That is laborious. You know that the V1 value is nothing but 14.14 meter per second, as is written here there to save your and our time there. 1.414 is root 2. Multiply with 10 on either side. Multiply with 10 on either side. 14.14 is equal to 10 root 2. Nothing is there. You can just see it, please. Similarly, 1.732 is, 1.732 is root 3. So, 1.732 is root 3. Multiply with 10 on either side. 17.32 is 10 root 3. Okay, so 14.14 we can write as 10 root 2 meter per second. And final velocity, minus 17.32 can be written as minus of 10 root 3. Now, our idea is to calculate what is the net work done. How to calculate net work done? So, the net work done comes out to be, come on, tell all of you, the change in kinetic energy of the body. Net work done is change in the kinetic energy. Change in kinetic energy means already we have seen K2 minus K1. So, half m common into V2 square minus V1 square. Just dump the values there. Half. What is the mass of the body? 4. V2 square. V2 is minus 10 root 3. V2 square means minus 10 root 3 whole square. Okay, so V2 square means, here I am writing minus 10 root 3 whole square. So minus square is positive there. So 100 into 3, it comes out to be 300. So V2 square is 300. Similarly, V1 square is 10 root 2 square. It comes out to be 200. So here it is 2 into 100 there. So the answer for the question is a simple 200 joules. So this is the total work done. So we did not get frightened with the graph in any way there. Now, suppose they ask, instead of work done, as they usually ask there, we are now interested about what is the average power delivered right in this 10 seconds time. Once again, recollect the basics which you are good at. So, average power comes out to be, everyone knows, the average power is nothing but total work done divided by total time taken. So, total work done divided by total time. Just now we have seen the total work done, 200 joules. Total time, 10 seconds. So, it comes out to be 20 watt. You know the unit of power there, 20 watt. That's the answer, my dear students. You should also be getting parallelly, okay? Then, once again, many times repeated questions in the Indian entrances. A body moves from some initial point, some position coordinates are given. A body moves from the initial point there. So what are the position coordinates are given means this is x1, this is y1, this is z1. So a body is moving from this particular point to a final point with x2, y2, z2. These are given. The body is moving not under the action of one force there. The body is moving under the combination of 3 different forces which are given. They are of different magnitudes. They are of different directions. They are given in terms of ijk's like this. Okay. Now, the body is consuming 2 seconds to go from that specified point A to B. It is taking 2 seconds to go there. I want to know what is the average power. Okay, naturally, average power means total work done by total time. Time is given as 2 seconds. Our only task is how to calculate the total work done. We have to calculate what is the total work done. Then, now coming to the point, total work done is nothing but work done by the resultant force. Work done by the resultant force. So first we have to calculate the resultant force. How do you calculate the resultant force? To calculate the resultant force, you students, even under little bit of exam tension there, you have to control it and do it a little bit in an orderly way. When you are talking about the resultant force there, F1 comes out to be 3I plus 4J minus 6K. This involves all ijk terms there, right as it is. Then comes F2. As far as F2 is concerned, 2I, don't write 3K here, there. Don't write 3K here. So there is no J term, no J term. So 0J plus 3K. Okay, this is the force in Newton. 2I plus 3K Newton. So the only thing is, make a note that you have to write 0J. Of course, you definitely know it. What is the third force there? So this is 4I minus 4J. And here, there is no K term, 0K Newton. Now you will be calculating the net force there. So what is the net force acting on the body means? This is the sum of these 3 forces there, F1 plus F2 plus F3. The net force means you have to just sum them up. All of you know resultant of the forces means their vector relation, F1 vector plus F2 vector plus F3 vector. If you add, you have to add F1, F2, F3. First add all i's, add I terms, 3i, 2i, 4i. Okay, it comes out to be 9i. Okay, so this is 9i. Okay, plus 4j minus 4j get cancelled. Then here it comes out to be minus, okay, even though it get cancelled, I'm writing a 0j, okay? Then minus 6k plus 3k. So this comes out to be minus 3k Newton. This is the net force acting on the body. There's a step number one. Of course, this question does have nearly 3 to 4 steps, but definitely we should not call it as a tough bit there. No question, no question. Maybe involving 4 steps, but highly moderate bit. So the net force is this much. Then comes the next point, how to calculate the displacement of the body. Every one of you know that whenever you know the initial positions, final position there, how to calculate the displacement of the body means the final position minus initial positions you have to subtract. X2 minus X1 into I. Yeah, we know those points right in vectors. So X2 minus X1 into I plus Y2 minus Y1 into J plus Z2 minus Z1 into K. So in terms of ijk, we write the displacement this way. So here comes x2 minus x1, 4 minus 2. That means 2i plus y2 minus y1, 2 minus 3, 2 minus 3. So this comes out to be minus j there. Yeah, 2 minus 3, minus 1, minus j. Z2 minus z1. Similarly, it comes out to be minus 3k. So if you happen to see there, so displacement comes out to be 2i minus j minus 3k. Okay. What is our next step there? The third point. We want to calculate the average power. How to calculate average power? Total work done by total time. Total work done is the work done by the resultant force. So what is the net force? Already we have seen. The net force we have seen it as, come on, tell me, 9i plus 0j minus 3k. This is the net force. What is the displacement of the body? So displacement of the body comes out to be 2i minus 1j. J means minus 1j minus 3k there. These are the force and displacements. So these are the force and displacement there. Then I want to calculate what is the work done. Work done is nothing but net force dot displacement. Already, that is an important point there. How to find dot product means we know. At the beginning of the class, we know F dot D means Fx dx plus Fy dy plus Fz dz. We have to leave ijk's and multiply the other terms. So when you multiply, please, fx dx, these two things, these two things, these two things we have to multiply and add, and you have to leave ijk's place. So 9 into 2, it comes out to be 18. When you multiply there, this is 0 there. So this is 0. Minus 3 into minus 3 comes out to be plus 9. So it comes out to be 27 joules. So 27 joules is the total work done. We want to know what is the average power. That's what I am saying. It may be a 4 steps question, but please note that 4 simple steps, 4 simple and important steps. I want to know what is the average power developed there. So average power is nothing but total work done by total time. Already we discussed. Total work done is 27 joules divided by total time. The time involved in the question is 2 seconds there. 27 by 2, 13.5 watt. That's the answer for the question. Okay, most of you definitely got the same answer, I'm sure. You're using the time, okay? The exam is fast approaching. Please make a note. Then the next 6th question. Once again, combination of kinematics, Newton's laws of motion, work power energy. 3 chapters combination, important model. Once again, many times question has come, of course, with different numericals and slightly different wordings. All of you know that this pulley structure is called as a Atwood's machine, as you are aware of. Now, in this Atwood's machine, one is a heavy body like 6 kg. The heavy mass we write as M1. The heavy mass will be we generally denote it by M1. M1 is 6 kg. The lighter mass, we are calling it as M2, that is 4 kg. Okay. Now, if the two block system is freely released, please make a note that the initial velocity is 0 there. The two block system is freely released. Find the work done by which force we want. I don't want net total work done, I don't want. Here I want work done by specifically the tension. The tension acting on 6 kg body. This is 100% keywording. I want work done by tension, that too specifically acting not on 4 but on 6. Please make a note. That too exactly in first 2 seconds. Okay, we want to know what the work done in first 2 seconds. We are taking G comfortably as 10 meter per second square. Okay, the question does involve good physics subject, please. Then, one of the important models we are now going to discuss. Listen. So coming to the first point. In the case of this Atwood's machine there, point number 1 is that, the first point is that whenever there is one heavy body, one light body there, you know what the formula for acceleration with which each block moves. Everyone knows that heavy body will be moving down naturally. The lighter body will go up. Yeah, heavy body will be coming down, lighter body will go up, each with an acceleration A. I want to know what is the acceleration. Recollect the formula of acceleration from Newton's laws of motion. Acceleration comes out to be G into difference in the masses, the heavier mass minus lighter mass by sum of the masses. Okay, trying to derive the formula in the entrance exam will eat a lot of your very valuable time. So at least some standard formula we need to remember there. So acceleration G into M1 minus M2 by M1 plus M2. Okay, here it comes out to be G10. Difference in the masses 6 minus 4, 2. Sum of the masses 10. So acceleration of each block is 2 meter per second square. So this is the first thing we got there. So acceleration is 2 meter per second square. So this is the value here. Okay, so here I am writing that particular value, which I have to use after some time there. So acceleration with which the heavier block is going to come down is 2 meter per second square. Why we are talking about heavier block is this is the 6 kg body we are bothered about. Yeah. The next thing is that you want to know what is the work done by tension in the string. What is the work done by tension in the string. Now listen. Work done by any force F comes out to be Fd cos theta. So to calculate work done by tension in the string, you must know tension. You must find out tension. How to find tension? Okay. Now, in the case of Atwood's machine there, the tension in the string comes out to be 2m1 m2 by m1 plus m2 into g. Once again, if you want to derive, at least it is nearly 1.5 minute program only for deriving tension there. How can you allot that much time for one small point of a good question? Okay, you have to remember. Then, so tension in the string is 2m1 m2 g by m1 plus m2. Now you know 2 into m1 m2 there, 6 into 4 comes out to be 24. Directly I am writing m1 m2 by m1 plus m2, 10 into g. Okay, so these two things get cancelled. It is as much as 48 newtons. Tension, no? Tension is a force. So 48 newtons. Okay, then The third point there, yeah, once again, four, four, four little bit of strong points in this question. So previous question I was telling, four easy points I said. So please believe your teacher. That time they were easy. And these are slightly moderate points. Then third one, I want work done by tension in the string. Work done by tension means tension into displacement to cos theta. I have to find its displacement. Whose displacement? Displacement of 6 kg body. How to find displacement of 6 kg body? Using simple kinematics. As far as 6 kg body is concerned, you know that its initial velocity is equal to 0. As you see here, these are the relevant points here. Initial velocity of 6 kg 0. Acceleration already we have found it as 2 there. And what is the time interval he is talking about? 2 seconds, first 2 seconds. Then you calculate displacement of the body. So this will be the third step there. So I'm just writing the step number 3 here there. So just I'm erasing this part there so that this is the third step. I wish that we are spending reasonably very good time of us for your sake, please. Selecting the proper bits, selecting the possible bits, and this work should go useful there, and you must be revising, please. Okay, then, so the third step here, u is 0, acceleration is 2 meter per second square there, and then time is 2 seconds. What is the displacement of the body? So S is equal to ut plus half at square, because uat you know. So ut comes out to be 0, half, acceleration is 2, t square is 2 square. So this comes out to be 4 meters. In what direction it is getting displaced down? Is we are talking about 6 kg heavy body, it is getting displaced down. Okay, now here comes the fourth step there, the fourth step. Now, as far as the fourth step is concerned, I want to know what is the work done by the tension acting on the 6 kg body. Okay, see here. All of you know, whatever force is exerted by a string, that is known as tension. Okay, this string will exert force on 6. It will exert some force on other body 4 kg as well. I want to know what is the work done by tension in the string, specifically on 6 kg body. Okay, this is the 6 kg body. Now, as far as 6 kg's body is concerned, in what direction tension acts means, you know one of the simple wording there. Tension in a string always act along the string end, away from the body under consideration. Tension always act along the string end, away from the body under consideration. So on this particular body, this tension will be acting along the string. Is intention I'm showing again, please. It acts along the string end, away from the body. This is the body now. So it is not towards the body, but away from it. So tension 100% acts up. Tension acts up, and its displacement is down. Its displacement is down. So what is the work done by tension in the string means? TD cos theta. Okay, work done by any force is FD cos theta. Here it is TD cos theta. Theta is the angle between T and D. Okay, what is the tension in the string we have seen? Already we have found the tension in the string is 48 Newton upward. Is now I am putting the arrow mark. This tension acts upward, we discussed. So tension in the string is 48 Newton up. What is the displacement there? This is 4 meters down into cos 180 degrees. Because tension up, displacement down, they are in opposite directions. Angle between those two vectors is 180. And cos 180 is equal to -1, you know. So if you substitute these things there, you get the answer of -192 joules. 48 into 4 is 192. So -192 joules. This is the answer for an important model. Yeah. Now we are talking about a work done by a variable force. A body moves under the action of a force F. given by F is equal to 2xi cap plus 3y square j cap. Find the change in kinetic energy of the body. Find the change in kinetic energy of the body as it gets displaced from origin. Origin means 0, 0, to some particular point. Do you know, some students will be unnecessarily tensed there. They think that mass is not given. Generally, kinetic energy means half mv square. If mass is given, we calculate kinetic energy. They worry a little bit. He is asking changing kinetic energy. Nowhere mass is given there. They think that mass data is missing. Not exactly. Okay? Then say, all of you in the class know that work energy theorem does say that work done is equal to change in kinetic energy. So work done, the body is moving under the action of only this particular force, understood? Yes, it is clearly said a body moves under the action of this particular force. So this is a net force. So work done by net force is change in kinetic energy. So in order to calculate change in kinetic energy, if you can calculate work done, that's enough. Okay? Then how to calculate work done when the force is variable? When the force is variable. Okay, already we have discussed the points there. This is something like this. So what is given the question there? It is given right in the bit that the force acting on the body is equal to 2x I cap plus 3y square j cap. What is the general way of writing a force vector means? Force vector comes out to be fx I cap plus fy j cap. So if you happen to see the NEET PYQs, you do find the work done by variable force several times. So here it comes out to be fx is equal to 2x and fy is equal to 3y square if you compare. So fx is 2x. So x varies, fx vary. Fy varies, fy vary. Now, how to calculate the total work done? So we want to basically calculate changing kinetic energy. I am writing that point first. Changing kinetic energy is nothing but the net work done. What the net work done means? The work done by this variable force. Okay, this net work done by the F, which is variable. Already at the beginning of the classes, we have seen, and even I have posted, see here. So work done under variable force comes out to be, just you have to turn to the back pages there. Then integral of, common term of you, fx dx plus integral of fy dy. Thank God there is no z term there. You can leave it. Okay, what is the integral of fx dx? Integral of 2x dx plus integral of 3y square dy. Recollect the integration knowledge you have. Okay, whenever you are doing integration there, this constant term should be brought outside the integral sign. You have to bring this constant outside the integral sign. So 2 into integral of x dx. At the starting pages, those were being listed out there. Integral of x dx comes out to be x squared by 2 plus 3 outside. Integral of y squared dy means y cubed by 3. It is a happy arithmetic. 2, 2, 3, 3 get cancelled. Every one of us know that after doing integration, you have to keep the limits. So what are the limits we have there? So all of you know, this origin, this is x1, this is y1, this is x2, this is y2. The body is getting displaced from origin to this point there. So here to here. So come on, all of you. So whenever you are writing the limits, the lower limit we write here there. Here you have to write x1 is 0. And here you have to write x2 is equal to 2. Here you have to write lower limit, y1 is 0. Here upper limit, 3. And recollect the basics of the integration there. So after you write the limits there, you have to substitute there. The upper limit we have to write 2 square minus 0 square is, and here it is 3 cube minus 0 cube. So you have to write upper limit in place of y, you have to write 3 first and then 0 there. And you have to simplify. When you simplify, it is a happy 4 plus 27. So this is 31 joules. So that is a change in kinetic energy of the body. Yeah, once again, I repeat that mass is not required there, and then there's answer for the bit. Yeah. Going for the next bit, please. From the top of a tower, you can see that a body is being projected obliquely. The height of the tower is given there. This is the height of the tower there. It is given as 25 meters. So from the top of a tower, a body is projected with an initial velocity of 72 kilometer per hour. So kilometer per hour convert into meter per second there. So I'm writing the steps directly. So 1 kilometer per hour is 5 by 18 meter per second. So this comes out to be as much as 20 meter per second. So the velocity of projection is given. The angle of projection is given as 60 degrees. As a matter of fact, there, that particular angle we never use or we need not use. That angle is surplus data. Okay, you will understand as we proceed further. Okay, then I want to know with what velocity the body strikes the ground. So from the top of it, if you project a body there, the body all the way go like this, and it will be striking the ground here with some velocity. Let us say this is the point A, this is the point B there. It will be striking here with some velocity. So what is the velocity of the body right at the point B? That's a question. So in some books, they give the answer very laboriously there. Then you can happily do the question. When the body is moving here, when the body is moving from A to B, the only force acting on the body throughout the motion is nothing but weight mg. Only one force acts, conservative force, nothing but mg. Already you know, law of conservation of mechanical energy. When the body moves under the action of only conservative force like weight and there's no friction, law of conservation of mechanical energy holds good. What does it mean? Total mechanical energy at A should be equal to total mechanical energy at B. Total mechanical energy at the points A and B are equal. What is the total mechanical energy at A? Potential energy at A plus kinetic energy at A. Total mechanical energy at B. Potential energy at B plus kinetic energy at B. Whenever you are talking about potential energy, there must be a reference axis, and you know that this good ground is the reference axis. The ground is the reference axis. Okay, what is potential energy of the body at A? mg into height of A. Kinetic energy at A, half mva square. Potential energy of the body at B, mg hb. Kinetic energy, half mvb square. Thank God that mass term get cancelled everywhere. Intentionally, they may frighten you. They may say that the mass of the body is 2.89 kilogram. Very odd value they may give. But that mass, we don't find anywhere, it get cancelled. Okay. The next point here is that G value is given as 10 there. G is given as 10. So here comes out to be G10. Okay. Then G is equal to 10 meter per second square. Height of point A is 25 plus half VA square. Right at the point A, it is being thrown with a velocity 20. So 20 square, it comes out to be 400. Directly I have written VA square. What is the height of point B? 0. When the body is at B, it is at 0 height there, laying on the ground, 0, plus half VB square. So a simple equation involving these things. This comes out to be 250 plus 200. Okay, this is 250 plus 200. So it comes out to be 450 is equal to half VB square. Yeah. So VB square is 900 and VB comes out to be 30 meter per second. VB is 30 meter per second. In the entrance examination, they may ask, find the velocity with which the body strikes the ground in kilometer per hour. Silently here they say kilometer per hour. Even under the exam tensions anyone will have, okay? Definitely, the reasonable tension will be there for anyone. Control it, and then you have to do the question till here in the SI system. And the last point, meter per second, you have to convert into kilometer per hour. If it is asked there, if it is asked 30 into 18 by 5 kilometer per hour. So every one of you in the class know that if it is asked in kilometer per hour, okay, what is the velocity in kilometer per hour? If they ask there, then I'm just writing it. 1 kilometer per hour comes out to be 5 by 18 meter per second. 1 kilometer per hour is 5 by 18 meter per second. Now we have to convert meter per second to kilometer per hour, 18 by 5. This get cancelled as many as 6 times there. Then this comes out to be 108 kilometer per hour. That's the answer for the question. Okay. Once again, same thing, my dear students there. Use the time, use the opportunity, try to get some additional marks in comparison to the method exam there. So if you got some marks X there, try to improvise the marks there. And please make a note that everyone will be in that particular process there. So have to do better than others there, and you need to have the edge there. And here we are trying to help you the best way. All the best, do well and use the time. Bye-bye.